What is the impact that high content imaging and artificial intelligence tools have on the accuracy and the interpretation of data?
I'm going to pick out, for instance, for Fabian Thijs, for example, the Campus framework, which identifies consistent landmarks, cellular landmarks. Because when you're doing sort of a deep phenotyping approach, where on each pixel you have a row of 80 different channels, and each pixel is and these things, it becomes very difficult to analyze that. These are methods which were developed to realize, okay, this actually is something which I find a lot, but sometimes that channel is missing, sometimes that channel is brighter, sometimes that channel is thin, or it's a bit, and thereby it actually tries to ignore the variability due to the compounds to find things which are consistent across it. And then they look at these things which are consistent across it and ask, how is it different in my control versus the compounds? And these are consistent things which end up being organelles and stuff like that, so that emerges from the data. So that's one thing where I think it helps you to interpret the data. You find that it is being by AI determined structures which you can wrap your head around. So it's not a black box. You know what it was, what kind of because you have the markers. You know what it is representing, whether it's a Golgi, whether it's a nuclear organelle or something like that. And then the other example again from the Thijs lab is where they're predicting cellular responses based again on data that you have acquired, where you're doing where you're extrapolating from the data you have, and then predicting these are targets. These are going to be the ones, the pathways which are going to affect this biology. So again, then you have now suddenly you're kind of fusing the target drug discovery world with the phenotypic drug discovery world, because you're using phenotypic drug discovery to predict molecular targets, which then you can then try with the molecular target. Maybe we might know structure, or we might predict the structure using, again, AI tools. And then we might, again, use AI tools to predict compounds and structures which would bind, inhibit, and change these things. So you reduce both the size of your screening deck, you get more certainty into what might be your target. This is always one of the big drawbacks of phenotypic drug discovery. You have to go and find your target, or at least try to really understand what the drug is doing. And you might have actually a convergence of these two fields by using AI tools. This is very exciting times, I find.
CELLIMA, science that works for you.